Particularly I'm impressed for this chemistry Waec. So it's not that we are going to meet the back titration, the one we talk about redox reaction and things like that. But this year practical is just straightforward and it's involving aqueous solution of H2SO4 and the one of sodium hydroxide. Now the first thing you have to ask yourself is this: what is a suitable indicator? Is a conc acid and is a conc base. So I think the suitable indicator for this year's chemistry Waec practical is methyl orange. Yes, methyl orange all the way. So teachers, you keep wondering. I have a methyl orange powder in the laboratory, but I don't know how do I prepare it. How do I turn it to a solution? Do I just bring it and add water? No. This is just the way to prepare methyl orange solution. If you have the powder in your laboratory, you bring it out. Weigh out 20 grams of your methyl orange. Use your digital scale. You weigh the 20 grams of methyl orange. You first of all add little ethanol inside it. Okay, just add little ethanol. Say like 20 cm cube. It's okay. You shake it very well so it will dissolve. By the time you dissolve very well, you now top it up with water to reach like 100 cm cube. Okay, you shake it very well. Store it in a dropper bottle or in a dripping bottle. You know that this is an indicator. You have to add it in drops, so it must be stored in dropping bottles. Now these year's practical, I'm beginning to wonder, these are some things we run on a yearly basis. At the end of the day, you see students, they will still make it up to expectation and all that. You keep wondering, is it that the students are not really hard enough or the teachers are not teaching well? But one thing I understand about Waec is Waec is just like every examination now bodies, they have these do's and don'ts. So if you be able to understand these do's and don'ts, it will also help you. Even though you know what you are doing, you should be able to follow the guidelines, the specific instruction for you to maximize your points in practicals. Like what I want to talk about is what you should do and what you should know. I'm not studying, I'm not writing anything, but if you know all these things at the back of your mind, it can help you to actually pass your exams very well. Now, if you are studying anything involved in chemistry or question, you don't have to write with a pencil. It's a punishable offense, and you know that whenever I say punishable offense, you are losing mark. Okay, whether do not just ignore you. They are saying -1, -2, as the case may be. Do not write it with pencil or in a pencil, whatever. Do not use pencil. That is just the English. And whenever you are collecting or taking a reading from your burette tab, your acid is in your burette, okay, and your base is in your conical flask. You are now titrating. Please make sure that you are taking a reading. Your reading has to be with the what? The concave meniscus. Don't go and read it from where when we say concave meniscus, is that the liquid that's inside the burette has this C form. Are you getting me? So at the tip of that water or liquid, your acid that you have put into, that is where you take your reading. Just at the bottom there. Don't go and read it from the other end or this side. No, at the tip, that is where you take your reading from. And if you are writing down your table, please make sure that you're also putting your answers in 2 decimal places. Let's say I take it from the meniscus and I'm getting something like 12, and I rush to my table and I write 12 cm cube. Yes, 12 cm cube is correct, but Waec says you must put it in 2 decimal places. So what should I do? Simple, 12.00 cm cube. It's as simple as that. And so also, if you want to calculate your average titer value, by taking the first reading, run the second titration, the third one, as the case may be, take the average. Okay, so my answer must be in 2 decimal places. I'm having something like 12.10, 12.01, as the case may be. Just let it be that it is in 2 decimal places. Then another thing is, after taking the average titer value, any other calculation you are doing, we have backup questions, right? So if you are doing those backup questions, make sure that your final answers is in 3 decimal places this time around, okay? Excuse me, it's in 3 decimal places. You don't okay, because your average titer value is in 2 dp, other one should be in 2 dp. No, it must be corrected to 3 decimal places. If you are asked to calculate the mole, the concentration, all those backup questions, they must be in 3 decimal places. And show full working too. Do not jump over. Then the another thing that students normally do is that they want their their title value, first reading, second reading, to be within the range of plus or minus 0.15. You think that Waec are not noticing all these things? Yes, it is very, very efficient and preferable if your range falls within the value of plus or minus 0.15. I don't know if I get what I'm saying. Assuming I run the first titration, I get a value of 11.10. I run the second one, I get a value of 11.3. The range is a huge one. So it should be plus or minus 0.15. That should be the range. So maybe I want the first titration, I want the second titration, I want the third one. The ranges are so wide, and I'm a kind of cleaning, counseling, altering my value so that they will fall within that range. Waec sees all this and you are losing your mark from it. But just be consistent with what you are doing. It will help you to maximize your points. No cancellation of tables. You end up leading yourself into much problems. Okay. Now for this H2SO4 and sodium hydroxide, you can actually prepare it from the stock solution. Sodium hydroxide is a strong base. H2SO4 is a strong acid. So if I get the stock bottle of Coke H2SO4 and I want to get smaller one, I can use to run from the practical. I'm talking to teachers now. It's very, very simple. The molar mass of H2SO4 is 56. Okay. Now I can simply weigh out with my conical flask 5.6 cm³ of this acid. Are you getting me? I will add it to water. Please, there's this mistake that should never be done. Please don't add water to acid. Very, very what? Very, very dangerous. Rather, you pour your acid into water. So I will add 5.6 cm³ of this conch acid, and I'll add it to 500 cm³ of water, and I will shake it very well, and then use another water, top it up to 1000 cm³ or 1 dm³. I've succeeded in preparing 1 molar solution of H2SO4. I can do the same for base. That's sodium hydroxide. It's a pellet. So what do? The molar mass of sodium hydroxide is 40. I get this sodium hydroxide, weigh out 4 grams of the sodium hydroxide, dissolve it in water, shake it, and make it up to 1000. Simple. I've gotten my mole concentration for that of sodium hydroxide. I can use it to run the practical. You don't need to use the whole of stock bottle because you want to run a practical. So that is what we call serial dilution. I've gotten the percentage that I want to dilute, and then we use it and run our practical. So in talking about quantitative analysis, from the series of practicals, if you have been following your teachers or you have been following Waec this period, you understand that we'll be having, at the end of the day, we always have our filtrate and our residue. Okay, so this Waec question, we are going to work with iodine, and normally there are some of these techniques that we know as chemistry students. When you are seeing iodine, what comes to your mind? You are simply going to test for starch. Okay, now testing for starch, are you going to test the filtrate or the residue? You are going to test for the filtrate, and you're going to test for the residue, but it depends on what Waec asks you to do. Normally in testing for the filtrate, you have to test either with aqueous ammonia solution or sodium hydroxide solution. Now, before you start separating the filtrate from the residue, there are 2 things you have to watch out for when you are starting your practical. You watch out for color change. They are giving you this compound and this compound, and they're asking you to mix it together. You are mixing, you are shaking. What is the first thing you have to look out for? Color change. This thing is white. Is it still consistent, or is the y changing to a clear solution? That is very, very important. You draw it down in your inference. And another thing you have to change is what? Bubblings. Are there some bubblings? Can you see some bubblings? We call it effervescence, where there is emission of gases. And some of the gas that we will likely encounter is what? The CO2 from the carbonate. So is there there's some bubblings that you can see? You note down this inference. Chemistry is very, very sweet. What you can see, smell, observe, write it down there. You don't need to speak too much English, okay? Now, there are some ions that are present that you need to test for. So, these ions, your teacher will guide you on how to run this practical. But make sure that as you are doing the practical, your eyes are there. You are seeing what your teacher is doing, so that you'll be able to draw this inference very well. And now, back to the filtrate. When you have filtered that, the first thing you have to look out for is to test this filtrate either with aqueous ammonia and aqueous sodium hydroxide. And because of the substance that we'll be working with in Waec this year, we'll be testing that and looking out for lead ion, that's Pb2+. That is what we'll be looking out for. And you know that lead sometimes behaves like an amphoteric substance. If because it's under, it has a oxidation number of +2. So if lead, okay, you put aqueous ammonia in drops, you add it to lead, you'll be able to see that there is a white substance that is there, white precipitate. You will be seeing it. It's very clear. And if you add the ammonia, aqueous ammonia, in excess, it will still be there. It will not dissolve. Yes, it will still be there. It will not dissolve. But then when you bring sodium hydroxide, you put it in drops. It's just there looking at you. The white precipitate of lead is there. You bring the sodium hydroxide in essence, and you see it. It will just dissolve. These are simple techniques. We run these things in examination every day, but sometimes students don't know the techniques or the idea what is actually happening with all these things. The good thing here that you might be interested to know that is that sodium hydroxide, aqueous sodium hydroxide, is a very strong base. So it has free hydroxyl to just give out. So when lead comes in, because there is excess of the free hydroxyl, it forms complex with the lead, and here it dissolves. The white precipitate of the lead will just turn into colorless. That's just that. But for that of ammonia, is a weak alkaline gas. So when you bring it in contact with the lead, whether in drops or in essence, it has a limited hydroxyl ion. It cannot dissolve. So you see it. So this is what you have to understand. Ammonia is a weak solution, whereas sodium hydroxide is what? A strong solution. This is why lead is able to dissolve in sodium hydroxide but do not dissolve in aqueous ammonia even in excess. And for the residue, the solution that we need have a starch solution in it. So you test it with iodine. Place your iodine in it. Look out for the change. You must see what? Blue-black coloration. So if it doesn't appear blue-black, it's either the mixture is wrong or you have gotten a bad compound, as the case may be. So whenever you are going into examination, you have to have in mind this is likely questions I'm going to meet, and this is actually I'm going to tackle with it. Are you getting me? So it makes you working with this confidence that I know what I'm doing. At least I'm 80%, 90% ready to answer this question. So do not forget, read very well, study, have an interactive classes, and very, very important, pray as well. I wish you all the best in this year's practical. If you are in alternative A, alternative B, I wish you all the best. I'll see you in my next video. Please subscribe to my YouTube channel and give me a message. Bye for now.